Local AI infrastructure and optimization. The persistent challenge of running massive language models on consumer hardware continues to drive innovative approaches to memory management and heterogeneous computing. PowerInfer, a project from Shanghai Jiaotong University, has attracted renewed attention following claims from TiinyAI that their pocket computer can run 120B parameter models on just 30 watts using this technology. The approach exploits a fundamental insight about neural network activation patterns. Not all neurons fire equally often. By identifying hot neurons, frequently activated, and cold neurons, rarely activated, PowerInfer processes them in parallel across different compute units. NPUs handle the hot paths while CPUs manage the cold ones. The skepticism in the LocalLLaMA community reflects healthy caution. As one commenter noted, "You could do 1T on 30 DOPS if you want, just going to be slow." A reminder that raw parameter counts mean nothing without throughput metrics. The deeper technical critique suggests PowerInfer's marketing may overstate its novelty. The approach appears to be generic CPU offloading of FFNs with attention being processed on NPU. The real constraint remains memory bandwidth, not memory capacity. NPUs have limited addressable memory, so the sparse activation pattern, roughly 2 gigabytes of activated parameters, fits the NPU's constraints. For genuine bandwidth wall breaking, speculative decoding, or diffusion-based language models may prove more fundamental. The TiinyAI device reportedly ships with 80 gigabytes of RAM at a Kickstarter price of $1,399. Expensive, but not unreasonable for such memory density. Meanwhile, the practical side of local AI continues advancing through clever software integration. A developer has released a fully local voice assistant demonstrating sub-second round-trip times on commodity hardware, combining NVIDIA's Parakeet ASR 600 mem parameters, Mistral's Ministral 3, 3B 4-bit quantized, and Hexgrad's Kokoro TTS 82 mem parameters. The entire pipeline runs on an RTX 5070 with 12 GB VRAM, with Kokoro alone adding only 200 to 300 milliseconds latency. The project also integrates Qwen 3 TTS for voice cloning, demonstrated using Dua Lipa's voice, raising obvious ethical questions about how easily one can synthesize convincing audio of real people. For those navigating the bewildering landscape of model-to-hardware matching, a comprehensive ranking of LLaMA models by VRAM requirements provides essential guidance. The spectrum is vast, from Cogito 2.1 demanding 250 gigabytes down to embedding models requiring just 0.04 gigabytes. The practical sweet spots cluster around 39 to 44 gigabytes for capable 70 to 72B models and 18 to 25 gigabytes for the 27 to 35B class that fits on consumer GPUs. Creative workarounds continue emerging for hardware limitations. One OpenWeb UI function intercepts images sent to text-only models, routes them through a vision-capable model on a secondary GPU, and forwards the description back to the primary model. AI agent development and orchestration. The question of how much autonomy to grant AI agents and how to verify their work moved from theoretical to intensely practical this week. A team from Coder conducted a 26-hour experiment where their autonomous coding agent, Quest, was tasked with refactoring itself. The results offer a sobering reality check on agent capabilities while demonstrating genuine progress. The headline, "Agent Rebuilt Itself," requires significant qualification. Human involvement broke down as follows: approximately 50% for specification design, 20% for actual coding, and 50% for code review. As the team acknowledged, they didn't just yeet a prompt and walk away for 26 hours. The preparation resembled onboarding a new engineer rather than issuing a magic command, breaking tasks into functional chunks, writing detailed specs with acceptance criteria, and reviewing auto-generated plans before execution. The agent worked through the interaction layer, state management, and core agent loop, substantial but scoped work. The technical architecture reveals the sophistication required for long-running agent tasks. Context management over 26 hours demanded spec decomposition into subtasks, automatic context compression as work progresses, and a reminder mechanism keeping critical information, file paths, key state, accessible despite aggressive summarization. For verification, addressing the grading your own homework problem, Quest employs multiple layers. Agents generate tests based on specifications but aren't blindly trusted, A separate review agent cross-validates execution against acceptance criteria, third-party test frameworks run independently, and periodic sanity checks trigger self-correction when drift occurs. For web development, the agent uses browser tools to actually click around and verify functionality. Is it perfect? No, but it's way better than trust me bro verification, the team noted. The broader agent ecosystem continues maturing. A multi-agent orchestration framework called iStack now provides a layer atop Claude Code via Model Context Protocol (MCP), enabling specialized agents, coder, researcher, tester, reviewer, to coordinate on complex tasks. The framework includes persistent memory with full-text search, multi-phase workflows with validation steps, and support for Anthropic, OpenAI, and LLaMA backends. At the commercial end, Human Emulator offers a glimpse of where agent technology heads next. Complete task automation described in plain English, with instant pricing based on complexity and volume. Their pitch: any digital task a human can do, faster, cheaper, and at infinite scale, covers data entry, invoice processing, tax preparation, and even autonomous coding from concept to production. Whether such promises survive contact with real-world edge cases remains to be seen. For those building their own agent skills, a new tool enables recording demonstrations via NoVNC, processing them with a VLM to generate semantic trajectories, and saving the result as transferable skill.d files compatible with both local and API-based agents. Model releases and technical advances. Hugging Face has released Transformers V5, the first stable version of their major upgrade, bringing significant performance improvements and API simplifications that address long-standing pain points. The headline numbers are striking: 6x to 11x speedups for mixture of experts, MOE models. The MOE improvements address what was frankly embarrassing performance. Transformers V4 used simple for loops for expert processing, causing massive GPU underutilization. 2 specific pull requests drove the gains, with more optimizations and specialized kernels promised. As one commenter wryly observed, if you improved performance 2x, you did something clever. If you improved it 10x, you stopped doing something stupid. The release also eliminates the confusing slow-fast tokenizer distinction in favor of a simpler API with explicit backends, and introduces dynamic weight loading that improves startup times while enabling MOE to work properly with quantization, tensor parallelism, and PEF parameter-efficient fine-tuning. On the model release front, GLM 4.7 arrives as a significant upgrade for coding and reasoning tasks. Compared to GLM 4.6, the new version shows substantial gains. WeBench verified jumps to 73.8%, 5.8%, SWE-bench multilingual reaches 66.7%, plus 12.9%, and Terminal Bench 2.0 hits 41%, plus 16.5%. The model emphasizes thinking before acting, and shows particular strength in multi-agent coding contexts when used with frameworks like Claude Code, Kilo Code, Klein, and Roo Code. On the Humanities Last Exam benchmark, designed to test frontier reasoning, GLM 4.7 scores 42.8% with tools, a 12.4-point improvement over its predecessor. Peter Devine, known for projects like LBReRanker and Suzume, has released Kakugo, a pipeline for creating language models for low-resource languages using only local infrastructure. The system prompts GPT OSS 120B to generate instruction and conversation data in a target language, then uses that synthetic data to fine-tune IBM's Granite 4 Micro 3B parameters. The pipeline covers 54 languages so far, from Amharic to Zulu, including languages like Scottish Gaelic, Mizo, and Papiamento that mainstream models typically handle poorly. The entire process runs on 8x3090 GPUs, keeping data sovereignty intact, an increasingly important consideration for language communities. Architectural research continues pushing efficiency boundaries. MHA2MLA VLM addresses the KV cache bottleneck in vision language models by converting standard multi-head attention to DeepSeek's multi-head latent attention architecture. The framework introduces a modality-adaptive partial row-P strategy that handles the unique positional encoding requirements of multimodal inputs, where images require distinct height and width position IDs alongside the temporal component used for text and video frames. Meanwhile, PaddleOCR VL 1.5 achieves 94.5% accuracy on OmniDoc Bench V1.5 despite having only 0.9B parameters. demonstrating that careful architecture and training can achieve state-of-the-art document parsing even at compact sizes. AI development tools and platforms. ChatGPT's code execution environment has received substantial undocumented upgrades that dramatically expand its capabilities, as documented by Simon Willison. The feature, originally launched as Code Interpreter, then renamed Advanced Data Analysis, and now perhaps best called ChatGPT Sandbox, can execute bash commands directly, install packages via pip and npm, and download files from URLs. The shift to bash execution is philosophically significant. As Willison notes, the key lesson from coding agents like Claude Code and Codex CLI is that bash rules everything. If an agent can run bash commands in an environment, it can do almost anything that can be achieved by typing commands into a computer. When Anthropic built their code interpreter for Claude, they centered it on bash rather than Python alone. OpenAI has now followed suit. The container now supports running code in JavaScript via Node.js, Ruby, Perl, PHP, Go, Java, Swift, Kotlin, C, and C++, 10 new languages beyond Python. Notably absent is Rust, though environment variables discovered in the container suggest it may be coming. Package installation works despite the container having no outbound network access, accomplished through an internal proxy at aceproxy1 openai.local880. The container.download tool allows ChatGPT to fetch files from URLs and save them to the sandboxed file system for processing, unzipping, parsing, analysis. These capabilities work on both paid and free accounts, confirming they aren't limited preview features. The tool ecosystem for teaching models new skills continues evolving. Hugging Face published a detailed walkthrough of using Claude Opus 4.5 as a teacher to generate specialized capabilities that can transfer to smaller, cheaper models, specifically teaching models to write CUDA kernels. The process involves 3 steps. Get the teacher model to perform the task interactively, create an agent skill from the execution trace, and transfer that skill to smaller models via the standardized .claude skills directory format that tools like Claude Code, Cursor, Goose, and Aider have adopted. An accompanying tool called Upskill automates generation, evaluation, and transfer. For those managing skills across multiple AI coding tools, SkillSync provides a single command to synchronize skill repositories to 14+ tools, including Gemini CLI, Claude Code, and Codex CLI. At the opposite extreme of complexity, NanoCode offers a minimal Claude Code alternative in a single Python file with 0 dependencies at roughly 250 lines, proof that the core agentic loop can be implemented with remarkable simplicity. AI cost management and token economics. The economics of context windows became painfully concrete for one developer who burned through 45 million Gemini tokens in hours while using OpenCode, an agentic coding tool. The experience highlights a gap between the theoretical promise of context caching and its practical implementation in agent frameworks. Context caching, in principle, should make repeated interactions with large contexts economical. Gemini Flash charges 1/10 the standard rate for cached context, but caching requires the agent framework to actually implement it correctly. OpenCode's internal statistics showed 0 for cache read, while Google's dashboard registered the full 45 million input tokens. The agent appeared to be sending everything as fresh, full-priced payloads on every request, completely bypassing the cost efficiency that Gemini's architecture enables. As the developer noted, 1/10 of the price is great, but 0/10 of the caching implementation is what's killing my wallet. The contrast with more sophisticated agent architectures is stark. One developer shared their tool agentic app, C-Line, which has processed 8 hours of daily usage for a month without approaching 44 million tokens total. The difference comes from intentional design. Semantic search tools use a secondary LLM before returning to the main model. Users can dynamically enable and disable tools, and a search tool allows the agent to start with minimal active capabilities and load relevant tools based on context. This kind of pipeline weaving keeps context clean and costs manageable. Billing anomalies aren't limited to token counting. One business user reported receiving multiple out-of-cycle API invoices from OpenAI, with 3 charges of several $100s each hitting in quick succession. The charges appeared as invoices in the organization's billing page, but didn't correlate with actual API usage. The user's frustration was compounded by OpenAI's support system, described as annoying support bots, unable to escalate to humans for what was clearly an urgent billing issue. Whether this represents a payment system bug, security compromise, or something else remained unclear, but the incident serves as a reminder to monitor API spending closely and maintain spending limits. AI ethics and legal implications. A provocative analysis examines what may become an increasingly common legal defense. The AI hallucinated. I never asked it to do that. The scenario presented is plausible and troubling. A financial analyst uses an AI agent to summarize quarterly reports. A competitor later receives confidential M&A target lists via email sent by the agent, but the prompt history has been deleted, and the original instruction is the analyst's word against the logs. The fundamental problem isn't the absence of logs. Most production agent systems log extensively. OAuth logs, append-only storage, signed timestamps, and retention controls can produce tamper-evident records that an event occurred. But in disputes, the question isn't whether something happened. It's who authorized this class of action, for which agent identity, under what constraints, for how long, and how that authority flowed. The gap widens dramatically in multi-agent systems where a human authorizes an orchestrator, sub-agents call plugins and external services, and the final action executes in a runtime that may not share your identity domain, audit system, or policy engine. The author argues that accountability requires an artifact that survives multi-hop execution, something analogous to how financial institutions handle real money. Banks don't rely on someone had a session. They require explicit authorization steps, step-up authentication, approvals, dual control, and maintain durable records of authorization decisions. In inter-organization rails, messages are authenticated so participants can verify who sent what. The check system evolved over centuries to produce auditable chains of accountability. Current agent architectures lack this property. A valid session token or broad integration credential can authorize actions the human never specifically intended, and when things go wrong, there's no cryptographic proof binding the human to a scope delegation. The agent can't testify. It can't remember. It can't defend itself. The AI did it becomes not just a convenient excuse, but a genuinely difficult claim to refute, creating what the author calls a liability gap between we recorded an event and we can produce a verifiable delegation chain for it. In a case that underscores the fraught relationship between security testing and legal exposure, Dallas County has agreed to pay $600,000 to settle a lawsuit brought by two security professionals who were arrested in 2019 while conducting an authorized security assessment of an Iowa courthouse. The penetration testers were performing work contracted by the state's judicial branch when local law enforcement arrested them for breaking into the building at night. The incident highlighted a persistent problem in physical penetration testing. Even with proper authorization, security professionals can find themselves facing criminal charges when local authorities, unaware of or dismissing the contracted work, treat them as actual intruders. The 6-year journey from arrest to settlement demonstrates both the legal costs of such misunderstandings and the vindication ultimately achieved by the testers. The case carries lessons for organizations conducting security assessments. Clear communication between all relevant parties, including local law enforcement, before physical testing begins, isn't just good practice. It's essential for preventing exactly this kind of costly incident. Authorization letters, pre-notification of police, and documented chains of approval can mean the difference between a successful assessment and a night in jail followed by years of litigation. Hardware and electronics. Beyond the world of AI, creative hardware projects continue demonstrating the accessibility of custom electronic tools. A MIDI pedal project for the Roland SP404 Mech2 Groovebox shows how straightforward it can be to build bespoke controllers for music performance. The build uses an Arduino Nano, or Uno, to send MIDI messages via its serial UART, housed in a pedal-style enclosure with a toggle switch for mode selection and a foot switch for triggering. The pedal controls various pads on the SP404, enabling hands-free operation during performance. It's a reminder that custom hardware doesn't require exotic components or deep expertise. An afternoon, a microcontroller, and some switches can open entirely new interaction possibilities with existing gear.